So which one first? I'm sorry, on page 62. Sorry. Which one did you want to see? 4B. You think the answer's wrong? I just want to see it.
I just want to see whether the answer is wrong or not.
Okay, fine. Anything else? I thought someone told me that they thought one of the answers in 3 was wrong. No? 3's okay? You think the answer's wrong? Okay. That's still a good reason. Alright, I'll do 3W and 4B then. And we'll go on to the next topic. So, 3W. 2 power 2x plus 6 minus 2 power x plus 7. Now, this definitely isn't the first time you're late for me, because I remember last time I said, this isn't the first time you're late for me, and you said, no, it is. So I know when I say, right now, this isn't the first time you're late for me, your answer is? No, the answer is yes. Ever. Sit down. Hurry up, come on, sit down. Now, x plus 7 plus 64 equals 0. So, in each of these I split them. This is 2 power 6, 2 power 2x, minus 2 power 7, 2 power x, plus 64 equals 0. So this is 2 power 6, 2 power x squared, minus 2 power 7, 2 power x plus 64. And if you look at this, this is like a quadratic. And you can see it's exactly a quadratic if you were to replace 2x with u. So you would see you'd get 2 power 6 u squared minus 2 power 7 u plus 64 equals 0. So you can see it is a quadratic. Mohammed S., how on earth are you late when I was on the same bus as you? What? In future, if you don't have time to get to my class on time, you can wait to get your food later. Okay? Because I'll give you a bit of a break between classes. Alright? And in future, if the teacher's sitting beside you on the bus, okay, just think ahead. Alright. Now, I've used the minus b formula here. So I get 2 power x equals minus b plus or minus the square root b squared, which is 2 power 7 squared, minus 4ac all over 2a. Now we can do a lot of cleaning up here. This is 2 power 7 plus or minus square root. This is 2 power 14. This here is 2 squared, and then this one here, what's it? 2, 4, 8, 16, 2, 6, is it?
It's 2 for 2 minus 2 for 2.
No, but 64 is 2 power 6, isn't it? Yeah. So it'll be 2 power 14 minus 2 power 14. This is, yeah. So it looks like it's the same as what happened last time, over 2 power 7. That just simplifies to 1. So you get 2 power x equals 1, or if you prefer, 2 power x equals 2 power 0. So then x is 1. Sorry. X is 0. 3w. Yeah, x is 0. Because you want to see it, or you think the answer's wrong? Alright, 3x. So, but I'll do it a bit quicker since we have the idea now. So 3x, 3 power 9x minus 84, 3 power x plus 81 equals 0. So this is 3 power x squared minus 3 and then cubed. No, 3 power 4. Is that 81 or 84? Oh, it's 84. Alright. 84. 3 power x plus 81 equals 0. So again, it's quadratic. Equals minus b plus or minus the square root b squared minus 4ac all over 2a. Ali, can you tell me what's inside the square root before you do a square root? Like, what's 84 squared minus this number? 17?
17.
And that doesn't have a square root, does it?
No.
The answer at the back is a nice answer. I wonder if I meant to put 80. Yeah, well, double check that. Is it 78? Oh, after the square root, it's 78, yes? Alright. 78 all over 6. Okay, 2 answers. Give me the plus and the minus answer, please. So, Ali, you give me the plus, or you have the plus, Naveed? 27. Okay, and the minus then?
1.
Okay. So you get 3 power x equals 3 power 3, or 3 power x equals 3 power 0, because 1 is the same as 3 power 0. X equals 3 or x equals 0. So what went wrong? You gave me the 78. Okay, I'm going to do 4b now. Okay. X power minus 7 over 6 over x power 3 over 4 equals minus 7 over minus 4. I cross multiplied. Okay. Here I get x power minus 7 over 6 minus 3 over 4 equals 7 over 4. So that means it's x power, what's this here? Put that in. Minus 7 over 6, minus 3 over 4, minus 23 over 12 equals 7 over 4. So that means x will equal 7 over 4 power 12 over 23 with a minus. Because if I want to cancel this here, I would need to put on both sides power minus 12 over 23. Minus 12 over 23, isn't it? What am I missing? This isn't the answer at the back? It nearly does. I think for the answer at the back, it's a little bit messed up. What I was going for the answer at the back was to write it like this. X is 7 power minus 12 over 23 over 4 power minus 12 over 23, which is 7 power minus 12 over 23, 4 power 12 over 23. But at the back I have 7 power minus 12 over 23, 2 power 25 over 23. Well, no, actually, I think it could be right, because you can change your 4 into 2 squared. What? It's not the same. No. It's nearly the same. This is what the answer should be at the back. But if I change this to 2 squared, I'd get 7 power minus 12 over 23, 2 power 24 over 23. Nearly. Close enough. And at the back I have 25 over 23. So this should be a 24 at the back. Yes. But by the way, for the exam, in the exam you could have stopped here. And you would have gotten full marks, okay? So there, it's fine to stop here, and you should stop here in the exam because you don't have much time. So stop there. Did somebody say where? Stop there. Okay, so we'll look at page 64 now. I need to change this. Okay. Logarithmic equations. So, last time we saw how to solve exponential equations. So now we're going to look at equations with log. There's no new rules, it's just the rules that we've done last week. First thing, let's do a different one. Yeah, let's say for example 1D. Now if I look at this, can anyone see what x must be to make this true? Nope. 81. Because if I had log 9 81, the answer is 2. Because 9 to the power of 2 is 81. But for question 1, I don't even want you to solve it. I want you to tell me for what are the allowed values for x. Basically actually I do want you to solve it. Alright. So most important from the first one is just what values of x you can use. Can anybody tell me what I must have for x? What can I use for x? Oh, worse than that. Not just any real number. There's a restriction. Multiples of what? Oh dear. X must be greater than 0. Yeah? So, this is what you might call the requirement. You need x to be greater than 0. Then you get the answer from just looking at this, really. There's nothing special to do here. And then the next thing you do is you check if your answer is allowed, and it is. If you're not sure how I got the 81, this is how I got it. Log 9x equals 2. So it's like this. 9 to the power of 9 to the power of 2 equals x. Because that's what this log means. It means 9 to the power of 2 will equal x. So 9 power 2 equals x. So x is 81. That's all there is to say about the first one. The thing you're supposed to learn from this first question here is the two parts of solving these. One is to write down what's allowed, and two is to get the answer and to check it. Okay? Whereas previously we never really bothered to write this down because we never had to worry about this, except for lesson 1 where we didn't want the denominator to be 0. Okay, but we'll look at more examples now. Can I scroll down? Yep. Okay, so we have 2b, 5 power x equals 4. Now last time we saw something like this. But last time we saw it, what did we do? We changed both into a common number. Like, for example, 2 squared on the right. But we can't make 2 power on the left. So, as you said, we saw this in physics yesterday. We have to use log on both sides. So what we do is we put a log on both sides, log and log. And you know that, that the x comes down. So this is the answer, log 4 over log 5.
And they cancel?
No, they don't actually. It's, they don't cancel. 0.8614. And here, there was no logs in the original. X can be any number. You're allowed to put any number here. So there was no need to write down any requirement, but if you want to, this is the requirement.
Will they ask us to do something?
Yes, they will. They'll ask you, the word that they often use is, they'll say, when is it defined? That means they want to know what is the requirement. So in the exam, you're looking for this word to mean what values of x can you use.
So, and the answer will be 0.861.
No, for just that part,
Yep.
answer would just be this. The question would usually be split into two parts. First part is the when is it defined, and then the second part is to solve it. So in the exam, this would be like 1 mark, and then this here would be like 2 marks or something like that, or maybe 3 marks. Okay. Number 3 now. Okay, it looks very similar. It's just a bit longer. 4 power 7x minus 7 equals 7 power minus 3x minus 6. Okay, same idea as the last question. You put log on both sides. So you get 7x minus 7 log 4 equals minus 3x minus 6 log 7. then what we do is we multiply this out. So these powers came down, and then we'll multiply them out. So here you get 7 log 4 x minus 7 log 4 equals minus 3 log 7 x minus 6 log 7. Just multiplying it out, but it's just backwards, that's all. Put the x's to the left. So you have 7 log 4 x plus 3 log 7 x equals 7 log 4, because this goes to the right, minus 6 log 7. If you look at the left, sorry, underlined the wrong thing. The x is in common on both. So we can say 7 log 4 plus 3 log 7 x equals 7 log 4 minus 6 log 7. So there's only one line left now. We just divide this underneath and we get x equals 7 log 4 minus 6 log 7 over 7 log 4 plus 3 log 7. Now, just a little bit of vocabulary check in here. If the exam question said find the exact value, then you stop here. But this is usually not what they ask. Sometimes they say this, mostly they don't. So if they were asked for the exact value, the exact answer, we stop there. But usually we have to go to the next step, which is 3 significant figures. So we have 7 log 4 minus 6. Oh, you have it already? The question says how many decimal places? 3 decimal places, okay. 7 log 4 plus 3 log 7. So, 2 decimal places. This answer will be minus 0.13. I've seen this in the exam many times. Okay. So next example is what do we do with 4a. It looks very similar to your homework question. 9e power 2x minus 3 power ex minus 6 equals 0. It's actually a little bit easier because you can already see that it's a quadratic. E power x squared minus 3e power x minus 6 equals 0. So using the quadratic formula, you have e power x equals minus b plus or minus the square root b squared minus 4ac. So there's 2 minuses there, so it'll be 4 times 9 times 6 plus 216 all over 2a, which is 18. So we'll get 3 plus or minus 15 over 18. So we have 2 answers. E power x equals 15 plus 3 divided by 18, so that's 1. Or e power x equals 3 minus 15, so this looks like it won't be an answer. Why isn't the second one an answer? What's the problem? It's negative. And e power x can't be negative. So we reject this answer. It's no good. And we take this answer. Now in this example it worked out nice. The answer was 1. But if it wasn't 1, if it was something like 10, you can't see what it is straight away. But all you have to do here... What we do here is we just put log on both sides. So we get x log e equals log 1. So we get x equals log 1 over log e, which is 0.
So do we use log or ln? Log is
No, it's not. No, it's not. It's not. When I say log and I don't mention a base, what base am I using? E. Yeah. So what's confusing about that? What? Hang on. Let me make something clear. I haven't. Okay? So when I say log, I only mean log base e, which is the same as ln. Okay? Yeah, you make note of this, please. One second.
Doesn't the line e cancel out?
Well, it's 1. It'll be 0 over 1, which is 0. Yes?
Why did you use the x on 1?
I know in that case it's easy to see what the answer is. Like if I had e power x equals 1, I can see that x equals 0. Yes? But I just did it because it's not always going to be like this. Most of the time it'll be something like that. So how do we take care of this? We put log on both sides. So the x comes down and you get x equals log 10 over log e. But this is really nice because log e is always 1. So the answer is just 10. But of course that makes sense because here you're saying e to what power makes 10? So the answer is log 10. That answers that question. I just did it this way, Ali, because it's very rare that it works out as a number. You can see the answer without the calculator, okay? So you need to put log on both sides. Okay, 5a now. So 5a is not about solving, it's about simplifying. May or may not be surprised to know that whenever I have something with x in the power, I in fact can always simplify it into this form. It's always possible to change this into this form. Always possible. And this form is very useful, especially for those people, especially for calculus. So for the people who've seen calculus before, this form is much more useful than this form because this has a derivative, but this doesn't have an easy one. Okay? But that's more about later in this semester, start of semester 2. So we won't worry about why it's useful, but it is useful to rewrite it like this. So now how do we rewrite it? Yeah, well first what I'll do is I'll at least split it. So this is 2 power 4, 2 power minus 9x. So that's the first thing I'll do. Then secondly, I'll go back to this in a moment, but I just want to give you a result here. If you think about it like this, x is the same as x times 1, of course, which is the same as x log e, right? Which is the same as log x. But what's log e? That's just ln ex. So in other words, what I'm saying is log and e cancel, leaving you just x. But it's useful in this example to go this way, to change x into log ex. And you can check it on your calculator. If you type in log e4, you know that the answer will be 4. So that's just a little note for what I'm about to do next. If you need to write it down, you really just need to write this down. Okay, so if I go back to the question now. So now this is 2 power 4. Oh, and I should also say, sorry, the other way around is true as well. You can also say x equals e log x as well, by the same logic. So you can say that or that. So for example, log e4 equals 4 and e log 4 equals 4. In other words, you can cancel e's with logs. Okay. Now go back here. So what I'm going to do is change this into not e, sorry. I think I can split it again. 2 power x power minus 9. And then I use my result from the left. I can change this into e log x. Minus 9. Yeah, or not? You don't seem happy. No, let me undo that. We're okay to here, right? Yeah, this is okay. All right. What would be the easiest way to do this for you? Yeah. What I'll do is I'll change this 2 power 4 to power x power minus 9. I hope there's not too many brackets. I've split it again. And the 2 here, I can change that into e log 2 x minus 9. What's up, Joshua? Don't do that. If you have a question, ask me. Don't sit down the back shaking your head like, that is not good. What's your question? Question? Oh, so this was shake of approval, was it? Disgust. Yeah. Now, all I need to do to finish is put these all back together. So when you have powers like this, how do they combine? They multiply. So you have, and what's 2 power 4? 2, 4, 8, 16. So this is 16 e power log 2 multiply minus 9 multiply x. So I'll just type in log 2 multiply 9 and I have my answer. The answer is 16 e power 6.24 x. So you can test it. If I put x equal to, say, 1, so I have 2 power minus 9 plus 4, that equals 2 power minus 9 plus 4, that equals 1 over 32, or as a decimal, 0.03. And then if I put 1 into this, I get 16 e power 6.24. Oh, sorry, I lost my minus here. Minus. And that equals 16 e power minus 6.24. It's the same. 0.03. So this is the same as that. I'll do another example of this one, okay? But this is a much more convenient form than this. Okay, I'll do another example of this. So I'm going to do 5b. Yep.
Pretty sure we have e to the power of equal to equal to e to the power 2.
Have which one? E power?
1 2.
Yeah.
How is equal to 1 to the power e power 2? Like I'm saying. Yeah.
How did I get this?
Yeah.
Okay. This is x. This is e log ex. What else is there to say? I could, I don't know, I could put log on both sides, couldn't I? So log here and log here. And you're happy with this one because I proved this one. This one? Yeah. So I use that result here. I get log x equals e log x. Sorry. That's not the right proof. Okay. X equals x, which equals x multiply 1, which equals, I need to get an e in it. Log, yeah. X equals e log x. I put log on both sides, but powers I can take down. So I get log x equals log x log e. But what's log e? 1. So you get log x equals log x, so it's true. So there's a little proof for you for why this is true. You put log on both sides and you end up with something that's true. Okay, where am I now? So write that down if you need to. I'm going to do 5b now. Okay. 5b now. 2 power minus 7x plus 4. That equals 2 power 4. 2 power minus 7x.
I can't stop here, but
There's another step. So we say this is 2 power 4, and then this here is e log 2, power minus 7x. Now what do we do with these powers? They multiply, and this is 2, 4, 8, 16. E power minus 7 multiply log 2 multiply x. So what is minus 7 multiply log 2, please? Minus 4.85. And that's the answer then. Another reason this is useful is you know what the graph of this looks like. So you could now graph this. Here is 16, and is it increasing or decreasing? Decreasing. Like that. But it's not so clear from this question what the graph looks like. But when you rewrite it like this, it is clear. So that's one use. Okay, last one here, 6a. Now number 6 is difficult. And I'll do 6a as an example. What you need to do for 6 is to use all your rules for logs to simplify and to solve. So with 6a here, I have minus 7 log 2x plus log x8 equals minus 6. Okay, who can tell me what the requirement is on x? Can x be any number? No, what must x be? Bigger than 0. So, that means if we get two answers, or more than one answer, we should only choose the answers that are bigger than 0. Okay. Now, the first problem is you can see that the x is in the argument and the x is in the base. This is bad. We should swap them. We should have them both at the same place. So we could swap these and put the x down in the base, or we could swap these and put the 8 down in the base. I would choose to swap these. Minus 7 over log x2 plus log x8 equals minus 6. Now, does anybody know why I picked this one and not that one? The swap. Not quite. No. Well, the reason is, if I was to choose this one, what would the base be? 8. And what's the base here? 2. So then I have another problem to deal with, which is to change the bases to be the same. So if I swap these, I'd have to use another formula, the last formula, that lets me change bases. So I'm saving one step by swapping these instead. Okay. Here, if I swap, what is the base? The base would be 8 if they swap. What's the base here? No, now, if I didn't swap them, if I kept it like this, 2. So this base is 2 and this base would be 8. That's a problem because they should be the same base if I want to try to solve it. And you could make it the same base. But what I'm saying is, if I choose to swap these, I have no problem with my base now because both are base x, the same base. So it's just a little quicker to swap this one instead of this one. Not wrong, just quicker. Okay, now we can say this is minus 7 over log x2 plus log x2 cubed equals minus 6. So this is minus 7 over log x2 plus 3 log x2 equals minus 6. Now, to simplify, to make it a little easier, what I do is I'll let u equal log x2, just so it looks a little clearer. So this would be minus 7 over u plus 3u equals minus 6. So it's a little bit easier if I look at this with a u instead of a log x2. this type of problem, we've seen something like it in a recent chapter. What should I do to try and simplify this? Multiply by u. So if I multiply by u, I get minus 7 plus 3u squared equals minus 6u. Well, what type is this? It's quadratic, isn't it? So I get 3u squared plus 6u minus 7 equals 0. But I should change it back now if I want. This is 3 log x2 squared plus 6 log x2 minus 7 equals 0. But anyways, it's still a quadratic, so we should use our quadratic formula. I didn't need to do that, just making it clear. Log x2 equals minus b plus or minus square root b squared minus 4ac. So that would be 4 times 7 times 3, 84, all over 2a, which is 6. Okay. So if I type that in, I get two answers. Log x2 equals 0.826 or minus 2.857. Now that's nearly finished. I just need to find the x now. But if you remember what log means, what this means is x to the power of 0.826, that should equal 2. And then here it means the same thing, x to the power of minus 2.857, that should equal 2. What power do I need to put on both sides to cancel this?
0.
No, 1 over 0.826. 1 over 0.826. And then here this would be 1 over minus 2.857. And then they go. So I have my two answers. 2 power 1 over 0.826. Oh dear. Okay. Right. That one is 2.314, and then this one here, 2 power minus 1 over 2.857. 0.785. Is correct? Yeah. Oh yeah, and let's not forget, I need to check. So what was my requirement for x? X must be bigger than 0. And both are. So we accept both these answers.
Does x always have to be?
No, it depends on the equation. Like for example, I won't do it right now, but if you were to look at, for example, 3b, the next one, don't worry, I'll put this screen back up. If you were to look at 3b, you have 8x plus 1 must be bigger than 0. And what else? And 9x minus 9 must be bigger than 0. Why? Because they're both logs. Can you see that in B? Literally the next one. 6b. Yeah, can you see why I said this? Yes? No? That's okay. Can you take log of a negative number? You can't. So what's inside the log in b? 8x plus 1. And what's in the other log? No. Both those numbers must be positive, or the log doesn't work. It's a bit like this, Ali. If you have square root 8x plus 1, this here must be positive because you can't have square root of a negative. It's the same idea. Now, that means x must be bigger than minus 1 over 8. And what about here? X must be bigger than 1, because this will be 9 over 9. Now, if I draw this on a number line, let's say here is 1, and then here is minus 1 over 8. You want x to be bigger than this number and to be bigger than this number. So therefore, x must be bigger than 1. That's the only way x will be will satisfy both of these. Okay. I think we talked a little bit about this when we did our inequalities with and. So you need x. Minus 1? Yeah, the problem is if I just said x is bigger than minus 1 over 8, it's possible that it's bigger than minus 1 over 8, but it's smaller than 1. So it wouldn't satisfy both. But if I said x is bigger than 1, then both must be true. X is bigger than 1 and, of course, it's bigger than minus 1 over 8. Now, if I said x must be bigger than minus 1 and x must be bigger than positive 1, if I just said x is bigger than positive 1, both must be true. And if you can't see why, I hope the number line helps. The first one is bigger than minus 1 over 8. The second one is bigger than 1. The only way to make both true is you just have x is bigger than 1. Then both lines are true. They both overlap. Yeah?
It doesn't account for the gap between minus 1 over 8 and
Yeah, you can't use x in that gap. Because if you use x in that gap, for example, if x was here, then this is true, but then this one here is false. If x is here, then this is false, and this is false. But if x is here, it's on both. It's true and true. So, Ali, for question 6b, you would only choose the answers bigger than 1. That would be a section B question in the exam. In the exam, it would be broken into 2 parts. This would be part 1, and then part 2 would be to solve it. So in the exam, in part 1, they'll say, what is the requirement, or for what values of x is this equation defined? So in the exam, they want to see this, and they want to see this. Sometimes they want you to put it together, and sometimes they don't want you to put it together. The key word you're looking for in the exam is each. Okay? If the question said, when are each defined, then you have 2. But if it just said, when is it defined, then they just want this answer. Okay? So in the exam, you're looking for each or it. Each means you can stop there, but it would mean you'd have to simplify. When are each defined? When is it defined? Okay. I'll give you a few minutes to do these now. So, this is an important one and it's difficult, which means you should practice a few. So I want the last 3 in each. And also, there's actually when you get time, there's a quiz on Moodle, a small quiz for the last chapter we did, sequence and series. So it's only like 4 or 5 questions, but you can test yourself to see how you're doing. Okay, so I want you working on these for a few minutes. Yes. So work on these for a few minutes, the last 3 in each.